We have seen how to find a complementary function of linear homogeneous partial differential equations with constant coefficient. In this video, we see how to find a particular integral. The solution of partial differential equation consists of two parts: complementary function and particular integral. If the given equation is a function of d and dz d dash operating on z with the function phi f of x comma y, then the particular integral equal to 1 divided by f of d comma d dash operating on phi of x comma y. This is the method of finding a particular integral. Now we see the various cases of the function phi of x comma y. The very first case is when this phi of x comma y is a function like e raised to ax plus by. Then in this case the particular integral will be, this is 1 divided by f of d comma d dash e raised to ax plus by. Here substitute d equal to a and d dash equal to b, and we get f of a comma b e raised to ax plus by. This is a particular integral when the function phi of x comma y is of the type e raised to ax plus by. Next case, second case is when phi of x comma y is a function of the type sine of ax plus by or cos of ax plus by. Then the particular integral equal to 1 divided by f of d square d into d dash square operating on sine of ax plus by or cos of ax plus by. The terms should be here in the form of d square d into d dash. Then we have to put d square equal to minus a square, d into d dash equal to minus ab, and d dash square equal to minus b square. And then particular integral will be 1 divided by f of minus a square minus ab minus b square operating on sine of ax plus by or cos of ax plus by. Okay, and the third case is the function of x raised to m or y raised to n. Phi of x raised to m into phi of x comma y equal to x raised to m into y raised to n. Then particular integral equal to 1 divided by f of d comma d dash operating on x raised to m into y raised to n equal to f of d comma d dash whole raised to minus 1 x raised to m into y raised to n. In this case, expand this f of f of d comma d dash whole raised to minus 1. Expand this term by binomial theorem in ascending ascending powers of power of d or d dash, and operate operate on x raised to m y raised to n term by term. We have to first expand the f of d comma d dash whole raised to minus 1 by binomial theorem in ascending powers of f d or d dash, and then operate on the term x raised to m into y raised to n. This is the third case, and fourth one is phi of x comma y equal to any function of x comma y, any function of x comma y. Then in this case the particular integral is f of d comma d dash into phi of x comma y, means those functions which are not come under the above three cases. Then how to operate this? First resolve this, resolve 1 divided f of d comma d dash into partial fraction partial fraction partial fractions, and consider f of d comma d dash as a function of d alone, function of d alone. Then particular integral equal to 1 divided by d minus md dash operating on f of phi of x comma y. This will be function of x, and we have substituted y equal to c minus mx into dx. What is c? C equal to y plus mx. Okay, so y is replaced by c minus mx, and you can see that it is easily integrable. When we integrate, then put the value of c equal to y plus mx, and again operate the second operator. So these are the four methods of integration of finding a particular integral.
Hello guys, thank you for watching video.